in calculation, we were not having tolerance. So that's why in the calculation, I was expecting that you guys will be using the value which was not having tolerance, okay? So this was the percentage difference you want to calculate. So another student have done in this way. So he or she did not use all the combination, but some of the combinations to see the difference. It's also right. I was not expecting you guys to use all the combinations, okay? But use different combinations to show the difference at the output, at the V out, okay?
I have a question.
Yeah.
Are you going over this because you want us to redo lab number 2, or you just want us to learn from our mistakes?
I want you guys to correct your mistakes.
So you want us to resubmit lab number 2 to you?
Yeah.
Okay.
Okay. I am discussing it because you don't have to redo it. You just need to understand the question and correct your mistakes, okay?
Okay. Thank you.
Because my point is not to deduct your marks from any lab report, okay? I just want you guys to understand what's going on. So it's not like I am not in a habit of just deducting the marks if I'm seeing something's wrong, okay? So I want you guys to understand it and correct it again, okay?
Okay.
Okay, so this is clear. Resistance tolerances are clear.
Yes.
Okay. Okay. Then this was, I think, causing a major trouble for most of you. So the power rating. Okay. So in the power rating section, I asked to find V load. Okay. That is the load that you are trying to find, which will give you maximum power rating. So the V load you have find is 9.08 volts. And V source for this V load was 11.8 volts. It means that if you have this V source, you will get this V load, okay? So that's good. So that's a good way of doing it, to understand what will be the V source and what will be the V load you will be getting, okay? Then you needed to find out the power rating across R1, power dissipation across R1 and across R2, right? So as you know that you have applied the voltage that will give you maximum power rating, so you were expected to get this value, which is very close to 250 milliwatt, which is its maximum power rating, okay? So that's why you are getting 100% almost dissipation at R2, okay? So that's what the point is, that if you applied 11.8 volts and that will give you maximum voltage across R2, you will be getting 100% dissipation here, okay? So if you make now the table, this table, you can use fewer values too. You can just do 0, 3, 5, something like that, okay? But if you see, okay. I think this may not be right. Just a minute, I have another value. So if you see here, in the 12 volt section, the PR2 percentage dissipation is 100%, right? That's what I wanted to see, that how you will make the dissipation table. And then beyond 12 volts, your dissipation continues to increase across R2, which means that if you increase the voltage beyond 12 volts, the dissipation will increase. And you will, because of the power rating, you are not expected to apply the voltage beyond its power rating. It's clear?
Yeah.
Okay, so that's what I was, and similarly for the calculation of the power rating, another thing I saw, which was not, right, that the rating, the power dissipation you get divided by the rating you have multiplied by 100 will give you the rating for R2 and R1. Most of you, some of you have used for R1 as 250 millivolts. No, 250 milliwatts. It should be 500 milliwatts. That's what it was mentioned in the circuit. Okay, so that's why your power dissipation should match what we are expecting, what we are expected to do. Okay, so in this, if you see, I don't think this is right, because if you see the 12 here at the 12 volts, the percentage power rating is not right. It should be 100%, because you are getting approximately very near to or something is wrong in this. I think
it's flipped.
Oh, it's fine. It's fine. It's fine. No, it's fine. So it's fine. So 12 volt I was seeing in this column. So 12 volts is giving you 100% power rating. That's fine. Okay. Similarly, it's increased like that. So it's good. Yeah. That's why I included this table. I was like, what's going on? Okay. So this power rating table is fine. So you have to, you know, understand this, that why we are introducing the power rating table. Okay, is it clear?
Yes, it's clear.
Okay. Now then this. So most of you have done this right. It's okay that you have shown that if I increase the series resistance, which is, of course, this is the hypothetical case, because the series internal resistance of a battery will not be this much, but we were just wanted to see that how much it will affect your V out. This was fine for both, for most of you. Okay, here the other thing is, which I have actually not included. So here, I think that was also fine, in which you were showing that there was a R load resistance, and R load resistance is creating effect on V out. That was also fine calculations for many of you. Okay, so then this is procedure 5, in which you guys have to, just a minute. In which you have to find the current across R1, and just a minute, I can show you this. Just a minute, I can include the circuit. Okay. So this was the circuit you were having, and you were supposed to find your I's and what you should say voltage. So this was a way of showing your calculation, which was very good. I mean, but I mean, you are not supposed to, you can use any method. It may not be, you know, too much tedious. It could be easy, but show your calculations, how you get your I's and R's and V's, right? So this is, your calculation may not be that much complex, but it's okay, whatever calculations you are using. And this is a good table in which you are showing how much calculated values you are getting, it's the simulated values you're getting, so it's okay. And then show. So what I was expecting you guys to show is your calculations and your simulations both. And similarly here, you were also showing your calculations for procedure 6 and how you are getting your simulated value. Okay, and for lab number 4, in which you are doing practical, so if once you have shown your calculations in lab number 2, you are not supposed to show calculations again for lab number 4. Okay, so if it's asked, you can just say that refer to lab number 2 and stuff like that. So you don't have to repeat your calculations if you think that, or you can copy paste as well, it's okay, but show your calculations and compare them with your calculated values. Okay, and this was the lab number 2 question, which I think I asked, and some of you have did not understand what I was asking. So I was asking that if you're increase your resistance or decrease your resistance, what will be the effect on the slope? So as you can see here, that your slope is inversely proportional to your R. So your slope will be steeper when you have the smaller resistance. Okay, so this graph I have just included to show you what it means. So if you have this smaller resistance, your slope is more steeper than when you have the larger resistance. Okay, is it clear? So this I actually have graded, so you don't have to correct this, but I really want you guys to look into your lab 2 and correct your calculations. Okay,
Will do.
okay, one more thing is I want to discuss some the LT spice circuit, because all of you I think did it wrong. Okay, just let me make it quickly and then I'll show you. And someone asked me for lab number 5, you have to do LT spice. Yes, you have to do LT spice for lab number 5. Okay. So you are finding this lab tedious? I mean, you think that it's too much work to do, or deadlines are harsh or something like that? You need more time to solve them?
Like in general, like are you specific about?
No, I'm asking in general, like the deadlines, and do you think it's tedious? You need more time?
I think the deadlines have been flexible, but the labs, like lab 2, just some take a while. I think it's just the structure, like, and you're doing a good job at explaining it right now. So deadlines, I think the deadlines are fine.
Okay. Anybody else? Do you have an opinion about them? Okay, let me explain what I was trying to explain in this. So there was a question in lab number 2 about shorting your R2 and R1, okay? So I was just trying to explain that. I don't know what was the values. So this was the circuit, I think.
Yes, like this right here was confusing in the lab.
Yeah, I was just trying to explain. So let's say this has 3.3K, I think. And this was 1K. This was, let's say 2K. I don't remember the values, but I'm just doing, I think this was the circuit. Okay, so my question was, let's say this is 9 volts. Okay, and I was just trying to introduce dot op, so we just will see the values, okay? So my question was, what will happen if you, or maybe I should say that this is your R1 and this is your R3. It's fine, I'm just trying to explain. It's okay if I have these values like that? Okay, let me, how can I change the variable? Something like that you were having. Then you having R2 here. And then you were having R3 here. And your R4 was here. Okay. So my question was that what will happen if your R2 was short, right? Okay. So, okay. Okay, so these are the values I am getting, right? So 9 volts, and I did not define the V out. Let me define V out, or V4. So this is my V4, okay? So these nodes I am getting. So I think this is V1. No, it should be V2 maybe, right? Because V1 I already have, or I can just change this. Okay. So I said, what will happen if you have shorted R2, right? So let's see what will happen. So right now, my V2 is 4.11. My V4 is 2.56, right? Is it clear? Do you understand what I'm saying? It's this, I think, last exercise on your lab 2. Where I was asking you what will happen if you short your resistances, right? It's where it is. So it's the last exercise. So you were having, okay, now I have values too. So you were having 2.2K, 1K. Do you remember the circuit?
Yeah, it's the very last circuit.
2.2K, 1K, 4.7K, and 3.3K. So this was 4.7K and 3.3K, and this was 20 volts. Okay. So these were the values we were getting, okay? So what I was asking that what will happen if you short your R2, right? So shorting means what? Shorting means that we want to reduce this resistance. To see that, or just you need to see what's gonna happen, let's see. If I just replace it with 1 ohm, what will happen? So you can see that with 1 ohm, your IR4 and IR3 is reduced to almost negligible, right? And your IR2 is the maximum current. It's almost the similar that is flowing. So in this loop, all the current will be flowing, and this loop is just getting out of the circuit, right? So I just have 1 ohm. So shorting means that you don't have any resistance. So it looks like the circuit that has only R1 in it, and it's just this circuit remained. Okay, so this circuit will be cut off from the circuit we were having. So what I meant to have R2 short, shorting means that you are shorting this wire, right? So shorting means that you will not have any current flowing here. So I cannot just, or you can also just replace it with wire 2 to see what will happen. Is it clear?
It's clear. I think I'd actually misunderstood this section because I thought it was like acting like R2 is not supposed to be there and then seeing what would happen, but obviously it's different. But thank you.
Yeah, so R2 shorting and open is, I think, maybe confusing, but shorting means that I want to short this resistance, okay? It is just replacing it with simple wire, then what will happen, okay? So this is one of the question. Now, if I just replace it with its own value, maybe 1K, the second question was, what will happen if I short 4.7K? Short means that you will just take this R3 out and replace it with the resistor, right? Or just replace it with 1 ohm, let's say. So it will not happen like that. Most of you have mentioned that this circuit will be out or something like that. No, this will be the same circuit, but now this circuit will behave like it has only R4 in it. Okay, so this circuit will have almost the same V4 as you have at V2 because this resistor has very negligible voltage drop across it. Is it clear?
Mm-hmm.
So shorting actually means that you are replacing this resistor with just a wire, right? So what we want to do is we want to see what will happen if we just short the circuit, okay? So that's what should be happening, that if you short this R3, this circuit, this branch will be there, but all the voltage drop will be across R4. Okay? Okay, so one more question in here was that if R2 is greater than R3, okay? So if your R2 is greater than R3, replacing it with 1 mega ohm, what will happen? So if your R2 is greater than R3, replacing it with 1 mega ohm, what will happen? So if your R2 is greater than R3, replacing it with 1 mega ohm, what will happen? So if your R2 is greater than R3, replacing it with 1 mega ohm, what will happen? So if your R2 is greater than R3, replacing it with 1 mega ohm, what will happen? So if your R2 is greater than R3, replacing it with 1 mega ohm, what will happen? So if your R2 is greater than R3, replacing it with 1 mega ohm, what will happen? So if your R2 is greater than R3, replacing it with 1 mega ohm, what will happen? So if your R2 is greater than R3, replacing it with 1 mega ohm, what will happen? So if your R2 is greater than R3, replacing it with 1 mega ohm, what will happen? So if your R2 is greater than R3, replacing it with 1 mega ohm, what will happen? So if your R2 is greater than R3, replacing it with 1 mega ohm, what will ha Well, what will happen? So 1 mega ohm, what will happen is you can see that your V2 and V4 increased, right? But as you have increased this resistance, the current through that should be very, very small. So you can see that current through this is very small, but your V2 and V4 increased, which is okay. So that was the, I think, questions which I included just to see your understanding about the circuit, that what you think, what should be the value of or contribution of your resistances in the circuit. Okay, so these were very important questions to know, that what is the value of your resistors in the circuit. Okay. Am I clear?
Mm-hmm.
Okay, so I think another question I was thinking to address. Let me just check quickly. Yes, so many of you have asked me the question that there is a question in lab 5 maybe, or lab 4. I think in lab 4, that over what range, I think this question maybe. Let me open it up. What was the question? Just a minute. Over what load resistance range could voltage divider design specification be maintained? That was the question. So I think, I don't know, you remember in the lecture I have mentioned that if your load resistance is 100 times your output resistance, that is your R2 or R out from where your V out is coming, then your output voltage will be maintained between your, plus minus 10% range. So if it is less than 100 times, like let's say if you have 1K resistor, your V load or the R load should be 100K at least, right? 10 raised to power 2 times greater, or 1000K should be. Then your V out will be within this range, okay? So you should mention that your R load should be 100 times greater than your R out, okay?
When you say R load, you're talking about the resistance in the voltage divider?
No, I am talking
total...
about voltmeters resistance.
Okay, so yeah, you're asking about the voltmeters resistance, okay.
Yeah. Okay. Are these questions clear? So the idea of ENG 214 is, what I want to take from this lab is that you guys understand the circuits, okay? It's not like we just put them in the breadboard. We need to know that also, that how these wires are going, that's very important part of it. But we also need to know the performance of resistors in the circuit, okay? The idea is not to, say that, oh, this is not good, you have not done. But I want you all to be very productive in this lab, okay? So I'm just not doing any lab today, and I think you have midterm as well. So you need to examine, I think lab 3 is fine, I am just grading it, but you need to examine that if you want to resubmit your lab 2, lab 4, it's okay, you can resubmit that. And lab 5 also, okay? If you have any questions, you can ask me regarding that, okay? But don't try to do so much calculations wrong. So, okay?
Thank you so much.
Okay, thank you very much. And yeah, that's about it. If you have any questions, you can ask me.
Are we already able to resubmit labs, or do they have to be opened up again? How does that work?
Yes, I will be opening it, but what you need to do, keep that old lab report there, okay, and just submit the new one.
Okay, so then like whatever we named it as, just name it as like, you know, dash resubmit or something.
Yes, kind of, yes.
Okay.
Yes, because in that way, I will be having your old lab report too, and then you don't delete your old one and just resubmit the new one, okay? Only lab 2, lab 4, and lab 5 is also due afterwards. Lab 3 is just fine. I am disregarding that, okay?
Okay, thank you.
Mm-hmm. Any other question?
For lab 5, do we have to do both a simulation and lab report?
Yes.
Okay, thank you.
You can ask, question if you have any question regarding simulation, but I did not do that because I thought that this is simple resistors and circuits, but it's okay if you are having some trouble and you can ask, okay?
Yeah, okay, thank you.
Mm-hmm.
This is just kind of a general question, but you know, the last 2 exercise problems for lab 2, when it talks about like, oh, what happens if this resistor is shorted?
Mm-hmm.
So even though it doesn't specify, hey, show the circuit in LT Spice and what happens, we should still do that. Like,
Yes, I did not do that purposely because it's like you can just see the circuit and say, oh, if R2 is shorted, what could happen? I don't mean it to use LT Spice for you guys, okay? So I just said that it's another way of doing it, or it's another way of knowing it, okay? What could happen if you
Okay.
don't know?
But it's not like we have to show the circuit.
No,
in
no,
LT
no, no,
Spice.
no. You don't
Okay,
have to.
That's
Yeah.
what I was curious, because I'm gonna resubmit that, and I wasn't sure if it was something you
No,
wanted.
no, no, no. You don't have to show LT Spice. You just need to know what will happen. If you just don't know, you can just verify from LT Spice, right? So it's just way of checking things. That's why I'm saying that we have 3 things. We have calculation, we have simulation, we have measurements. So we can verify our scenarios through 3 things. Okay?
Got it. Yeah, I think the one thing with lab 4 was there were times where like, I don't know, like the language of like the load resistance, I had interpreted the load resistance as like the total resistance in the circuit that the voltmeter is measuring. So I think I ended up saying like, instead of it being like it has to be 100, like the load resistance has to be 100 times, I said like it's 1/100th, because that's the 1/100th of the resistance of the voltmeter. So I think there's just times where like sometimes we get, or at least I get confused about how the problem's worded.
Yeah. You can ask me. I mean, yeah,
I appreciate you clarifying.
Yeah. It's okay. 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 Am I clear? Are we good?
Yeah.
Okay. Thank you very much. And
Is there a set time where we have to resubmit it, or is it just the same time as lab 5?
no, I will update the dates. So I think we'll give you this week, next week, to resubmit that. These 2. Okay.
Thank you so much.
And are you gonna upload the recording to this?
Are you what I will upload?
The recording?
Yes, I will upload the recording, but I will not upload this. I'm not sure. I'll not upload this solution that I have prepared.
Okay.
Yeah. Okay. Is it good?
Yeah, I think we're all good now. Have a great weekend.
Thank you.
You too. Thank you very much.
Thank you. Have a great weekend.
You too. Thank you. Bye.
Thank
Have a
you.
good weekend. Bye. See you next
Bye.
week.
See you.
Best lab circuits teacher ever.
Oh, thank you.
No
See you.
problem. No problem.